Looking
Okay,
good.
I think we're ready to start. Hello, everyone. Thank you again for joining us for the November Green Chemistry Connections. We're very excited to have our wonderful panel of speakers who will talk about lab safety, specifically not so scary alternatives to some chemicals and stuff that we use. So we'll get started now. So this is our team. My name's Gagan. I'm actually the third one at the top.
And I'm Sarah. I'm in the middle. But yeah, I'm a PhD student at McGill University in Canada.
Hi, everyone. My name is Jasmine Hong. I am the first one at the top, and I'm also a PhD student in Canada at McGill University.
And my name is Tessa. I'm a PhD student from Monash University in Australia. So we're around the world now.
Yeah, and we also have Adele, who's also from Australia, who wasn't able to join today, but is a wonderful member of our team.
Hi, everyone. My name is Sarah, and this year I'm an ambassador for the Green Chemistry Connections webinars, and I'm a PhD candidate at Memorial University of Newfoundland.
Hello everyone, I'm Michelle. I'm also an ambassador this year and I'm doing my PhD at Concordia University in Montreal.
So first, we just want to thank our sponsor, Millipore Sigma, for supporting this. We wouldn't be able to hold this event without them. And also, before we begin, we just want to do a few land acknowledgements. So a number of us organizers are in Montreal, so we'll just read the land acknowledgements for McGill and Concordia. So McGill University is located on land which has long served as a site of meeting and exchange amongst Indigenous peoples, including the Haudenosaunee and Anishinaabe nations. McGill honors, recognizes, and respects these nations as the traditional stewards of the lands and waters on which we meet today.
And we would like to begin by acknowledging that Concordia University is located on unceded indigenous land. The Kanien'kehá:ka Nation is recognized as the custodians of the lands and waters on which we gather today. Tiohtià:ke, Montreal, is historically known as a gathering place for many First Nations. Today, it's home to a diverse population of Indigenous and other peoples. We respect the continued connection with the past, present, and future in our ongoing relationships with Indigenous and other peoples within the Montreal community.
We would also like to acknowledge that the lands on which Memorial University's campuses are situated are in the traditional territories of diverse Indigenous groups. And we acknowledge with respect the diverse histories and cultures of the Beothuk, Mi'kmaq, Innu, and Inuit of this province. Thank you.
Yep. And before we get started, we just want to go over some logistics of the Zoom setup. For the Zoom display name, you can rename your name to include your pronouns so everybody can identify and address people in the way that they want to and be respectful. Additionally, you can also enable live transcripts using the CC button at the bottom of your screen if you'd like to. And lastly, slides and the transcripts will be made available after the connections for your viewing.
We'll just also go over the code of conduct for green chemistry connections. So at Beyond Benign events, we want everyone to feel welcome and included. By participating, you agree to treat all attendees with respect regardless of their identities. Discrimination or harassment of any kind will not be tolerated. There are no consequences for reporting inappropriate behaviors. Beyond Benign reserves the right to determine what constitutes appropriate behavior or unfair treatment and will take appropriate action as needed. Thank you for helping us create a safe and supportive environment for all. And just as a general guideline, once we open the breakout rooms, just make sure you speak up, introduce yourself, and then step back to give others the space to introduce themselves as well.
Hey all, I'm Chloe DeFlumeri. I am Communications and Events Coordinator here at Beyond the Nine. You might know, you might not know, tomorrow night we're having our Observe, Wonder, Think for the month of November. Our coordinator, Esther Hines, will be talking a bit about green labs. This is more for a K through 12 audience, but I know that we might have some K through 12 folks out tonight. So if you're free tomorrow night as well, this is more like a small group conversation. You can bring your questions, your comments, or any needs you have for collaboration. We hope to see you there.
So on today's agenda, we have 4 amazing speakers coming up. And first with Professor Jane Wissinger, then followed by Cassie, two Cassies, then a breakout room for all 3 of those speakers, then a short break, followed by Elizabeth Brown, and then more breakout rooms, and then we'll do a wrap up. So I'm going to segue now into our first speaker. So Professor Jane Wissinger is a Professor Emerita at the University of Minnesota. She received her Ph.D. in organic chemistry from Northwestern University. At the beginning, her academic career was at the University of Minnesota as an organic chemistry laboratory director at the beginning. In addition to modernizing the organic laboratory curriculum, she taught organic chemistry lecture courses as well as an upper division green chemistry course. Her teaching and research programs focused on the development of new curriculum materials for the college and high school levels that exemplified modern green chemistry methodology advances in sustainable polymers, systems thinking, and guided inquiry pedagogy. She was also a senior principal investigator in the NSF Center for Sustainable Polymers and is passionate about educating students and the public about the need and opportunities for designing better plastics. Though recently retired from teaching, August 2023, she remains active in promoting green and sustainable chemistry and the UN Sustainable Development UN SDGs locally and on a national and international level through the high school teacher workshops, publications, and as a conference symposium organizer. So I'm going to pass over to Jane. Thank you.
Thank you so much for that kind introduction. Oh my goodness. Now I'm looking for my slides. You cannot see them yet, can you? Let me see.
No, I think you have to share screen.
I know. Okay. Does that look good? Okay, I'm so happy to be here with all of you, and thanks for joining us. I want to start off by saying I'm from the University of Minnesota, as was stated, and also give a land acknowledgement. The University of Minnesota was built on the traditional homelands of the Dakota people. It's important to acknowledge the peoples on whose land we live, learn, and work as we seek to improve and strengthen our relationships with our tribal nations. If you haven't been to the University of Minnesota or Minnesota, come join us. It's a great place to be. So I am the kickoff speaker here. So I'm going to set the stage by talking about the intersection of green chemistry, safety, and RAMP, the tool called RAMP. And I'm also going to share some just snippets of implementations in different teaching labs. I am an organic chemist, but I pulled in some analytical and some inorganic and general chemistry and biochemistry labs just to tease you a little. And then I hope to talk more in our breakout rooms of other questions and other resources. Along the way, I'll talk about benefits and how important it is to prepare our students to really have a strong safety mindset and culture. And I'll probably just waive the resources watching my time here so that we can talk about them, or they will be shared with you after the webinar. So of course, as chemists and scientists, safety is of utmost importance. And the American Chemical Society on a national level recognizes this and has a policy. And so I'm going to share snippets of the most recent 2023-2025 policy. And that is, I think it's really significant to note that the statement is that we as scientists and chemists have an obligation to protect the safety and health of the individuals, those of us doing the chemistry, as well as in the environment. And I believe that's the big tie to green chemistry. There's a section of this policy that is specifically on chemical education. That is, we should be educating our students and to be responsible scientists, engineers, and teachers based on understanding how to do risk-based assessments of safety. And I'm going to talk a lot about that. What I think is so cool is that this cool tool called RAMP, recognizing hazards, assessing risks, minimizing risks, and preparing for emergency, came out of the chemical educators Hill and Finster. And now the National Society puts this forward to the whole chemical enterprise, industry, everybody, as a tool and a mechanism to really assure safety as we work. I also want to highlight that this policy has a safety and sustainability component to it, highlighting the adherence to the tenets of green chemistry. So I have to acknowledge Cassie Leiden for this slide that we use in our teacher workshop in green and sustainable chemistry, where of course what you can see is green chemistry is about reducing hazards, designing safer chemicals, safer solvents, real-time pollution prevention, and preventing accidents with safer chemistry. So quickly, I'm also going to talk about for all you higher ed participants in this webinar, the new ACS guidelines. Now, safety has always been a part of this, but they modify it, and I want to really highlight some of the modifications. And most exciting this year to all of us in the green chemistry community is that green and sustainable chemistry is part of the requirements for bachelor accreditation. So creating a safety culture is important. And let's see, Chloe, can you see my arrow? Can you see my arrow?
I cannot.
Okay,
Oh,
no,
yes,
wait.
I can. Wait.
Oh, laser pointer. I got it here.
Amazing.
Woo, it's been a while since I've been on Zoom. So creating a safety culture under the normal expectations, so critical requirements, you have to do this. Normal expectations, teach students about RAMP. And then safety culture also has a community component to it. And that it's not just about the safety officers walking around with their big sticks saying, you're not doing things right. It's about everybody participating and understanding how important having a safety mindset is for everybody and for the environment. Under training and education, I also want to highlight that programs seek reduction of chemical use and hazardous waste generations and embrace green chemistry principles. So we're looking to do that with looking for incorporating safer alternatives. For green and sustainable chemistry, a working knowledge of the 12 principles, looking at case studies, and then certainly talking about the safety and designing better alternatives. So if you look at RAMP, I'm going to talk just a little bit about it in green principles and do word cloud. There's a lot of intersection. Safer processes, reducing hazards, etc. Designing, minimizing, risk assessment. So this is the National Institute for Occupational Safety and Health, and I think this is really important to recognize that we all want to train our students in, if there's hazards, what to do. But if you look at what's the most effective way to assess the risk of a process or transformation you're performing, it's a function of the hazard and exposure. And using PPE and hoods and all that are the least effective ways because they can fail. In contrast, reducing the hazards by elimination or substitution, which is where green chemistry comes in, really seeks to, it is here, and that's where you can really make the case to your department and colleagues that incorporating green chemistry reduces the hazard and therefore reduces the risk. And so these are the acronym RAMP, recognize the hazards. And I'm going to be totally honest, I never got around to teaching it specifically as RAMP. But what I did do, and I bet many of you do, is have students recognize the hazards by looking at the SDS and GHS sheets. Assess the risks by thinking about the experimental planning and function. Minimize the risk by using the tools of green chemistry to find safer options. And then, of course, prepare for accident prevention by really understanding the experimental cautions and protocols. A strategy that many higher education instructors like to take is, of course, guided inquiries, discovery-based, and having students go in and say, what would be safer? And this is very important that the instructor is involved in making these decisions, because we don't want regrettable replacements. You know, there's some chemistries you just can't do in water, that it would be dangerous. So it's really applying chemical knowledge to make these decisions is how we're training students to be prepared. So I was the organic laboratory director for 25 years, and my goal was to modify the curriculum for green chemistry approaches. I wanted to have students know modern practices of organic chemistry, replacing solvents, greener reaction conditions, which the benefit was that, I'm seeing the picture, that reduce the waste by approximately half. And when we reduce waste, what do? You reduce the cost of handling the waste. And it's safer, less hazardous waste by removing strong oxidizers, such as caused this, nitration sulfuric acid mixture that caused this explosion in the waste hood of the teaching lab. I'll real quickly say that you can reduce waste by really teaching students how to wash their glassware. Once they learn about acetone, it's like, all over the place, even with aqueous solutions, and it's not necessary. So a quick video on how to wash your glassware reduces waste as well, and it's safe. All right, so I'm just going to give you a few examples of implementing in the curriculum. So classic organic chemistry experiment, even at the high school, all across the, different education levels, is making those sweet smelling esters. So we made banana oil. It smells so good. It's the attack pheromone of the honeybee. And classic way to do this is with mineral acid, sulfuric acid, or phosphoric acid. A safer way to do it is with these amberless beads, so a solid supported acid catalyst. So in my laboratory for a long time, we were doing this second experiment that was making this really cool fluorescent compound. Depending on the pH, it's different colors. And we use the amberless beads. But modifying the curriculum, it was simple. It wasn't simple. It took some work. Of course, it always takes work to change curriculum. We replaced the sulfuric acid with these amberless beads. Students themselves are recycling them and regenerating them. This is what they look like. You can teach a little bit of polymer chemistry here, that the sulfuric acid on these little beads, so much safer to handle than pouring a mineral acid or pipetting or anything else. These beads are really easy to use and deliver the catalytic amount of, acid. All right, there's one example. Another is a classic oxidation done that they learn about in organic chemistry lecture, oxidizing a secondary alcohol to a ketone. I can't believe anybody's still doing chromic acid. A lot of people are using bleach. We took the literature, and so I want to encourage you all. There's so much great literature out there now on green modifications and how to do chemistry in a greener way and safer way. And so we took a literature procedure using a greener oxidizing agent. The waste is much safer. You don't have the problem of inhalation of bleach vapors, much safer. The chemistry works great. Let's see, right. Come on. Oh, can still meet all my learning outcomes of proton NMR. But yes, the atom economy is poorer, as with many oxidizing agents. So there's always lessons. We always say greener or safer. It's never 100%. And as you've noted on these slides, I'm pulling out some of the green principles that have to do with safer. Okay, one really important concept, I think, is whatever you're an instructor of, whatever classes you're teaching, I know you have learning outcomes. You have to teach the techniques or these concepts. So we have instrumentation we want to teach, reinforcing lecture, how to communicate science, and you can do this all with teaching greener and safer chemistry. And so about 85% of my laboratory had incorporated these concepts of solventless reactions, catalysts that weren't from endangered elements, solid support, tandem one-pot reactions, etc. All right, so going on to some other types of lab, maybe some of you are doing life sciences, general chemistry, or biochemistry. Here's an experiment that talks about bioplastics. All the starting materials are really inexpensive and safe to use: citric acid, glycerol, and starch. You can make a polymer and analyze the degradation using Beer's law plots. Release of the dyes can be analyzed. So really meeting some very common life science biochemistry type experiments. You could do kinetics if you want, etc. Analytical chemistry is really addressing a lot of green chemistry now and safer chemistry. I wanted to highlight this recent publication by Andy Dix on greener, more sustainable analytical chemistry laboratories. And I just had a great time today looking through the literature on all the new innovations in instruction and analytical chemistry. I never knew there were 12 principles of green analytical chemistry, and certainly safety is involved with less toxic reagents, eliminate or replace, safe for operations, etc. So here's just one recent publication I pulled out of the Journal of Chemical Education. But particularly for analytical chemists, there was a lot of great literature in primary journals like Green Analytical Chemistry. So solvent selection guide should be the part of any instruction in undergraduate laboratories. There's so many good ones to use. The ACS Green Chemistry Institute has good resources there. And I just want to highlight again, in analytical chemistry, certainly the solvents and the quantity of solvents with analytical chemistry is something to be addressed. And again, I found a great paper in ACS Environmental AU. This is open access, and companies themselves are advertising these safer tips on using the common tools of analytical chemistry. I've been particularly interested in peptide synthesis, and because the most common solvent used in peptide synthesis is dimethylformamide. That is not a good chemical to use. And there's also sensitizing coupling agents. So there's a few great resources here to replace, if in your biochemistry laboratories or specialty laboratories, improved mechanisms for forming amide bonds. Oh, I gotta go. Okay, one last comment. And that is, don't forget to connect with your environmental health and safety people. They are so anxious to improve safety. and they want to work with you. I found such great collaborators in our EHS to evaluate protocols. Knowing how they manage the waste can help you, and particularly students, and help build a culture of safety through collaboration and understanding instead of compliance. Also, stockroom personnel, have them buy some safer solvents. Have them not stock so much of the solvents that are not in chemicals that are not so safe. All right, so I have a lot of lists of resources. I'm just going to flash these up because my time is up. And I know that we'll be talking about the green chemistry teaching and learning community that has many of these resources. And conclude, so that you can hear the Cassies, that green chemistry goals and safety goals are very synergistic. It will enhance the safety of your students and train them for their jobs, working with your environmental health and safety personnel. Could be a good collaboration and motivation. And we are training students, and the industry is so interested in having students that have already been trained and have a good mindset of safety in their future careers. Okay, so that's the end. And I look forward to seeing you in the breakout room, I hope.